And this is the area of a rectangular picture frame, and we want to find the possible dimensions of it, and we want to use factoring. So let's remember what factoring does. Factoring asks us to go back to 2 parentheses here that multiplied to give me x squared minus 3x minus 28. So the first, because there's no number in front of x squared, I know I can put x and x here. Then I asked myself, what two numbers multiply to give me negative 28, but add to give me negative 3? Let me say it again. What two numbers multiply to give me negative 28, but add to give me negative 3? Think about what multiplies to give you 28. 1 and 28. Of course, we got to think about negatives. 2 and 14. Oh, no, 3. 4 and 7. Looks like the 4 and 7 is going to be my best combination if the 7 is negative. So I'm going to put a minus 7 here and a plus 4. Remember, what two numbers multiply to give me the term without a variable, but add to give me the term with a variable? And there is my answer. Yay! And we're going to use the Desmos graphing calculator. I'll be sure and link it in the description below so that you can use it pretty quickly, and you definitely want to use it on your semester exam. So let me switch views so you can see my Desmos graphing calculator. And I'm just going to graph this function, y equals 0.4x squared. It's really simple in Desmos. You just type it, y equals 0.4x. Now the caret is the shift 6 to get in that exponent, 2. And there it is. Now the other beauty of Desmos is you can go over here and hover, and it'll tell you some points. You can go over here and let's see, this one looks pretty good. You can click on it, hold your cursor down, and it'll tell you the value. So that's about 3 and almost 4. So 3 and almost 4. You see how I got some values then that I can graph with? Super nice. Let's see if we can get this one. That one's negative almost 5 and almost 10. So negative 5 and almost 10. And then other than that, I just want to draw my general shape. Okay. That's super nice when you can use your Desmos there. Now, the domain, that's referring to the x's. And so I can put in any x here. So my domain is going to be all real numbers. And my range, I want you to see that all my y values are 0 or higher. So I can say that as y is greater than or equal to 0. And I do that from my graph. I'm looking at my graph to be able to tell that. We're given a nice equation there in number 16. It always makes me think I should be using Desmos. And like I said, I'll fix this when it comes out to you, but that should be t squared. And we want to answer some questions like, how long does it take the pumpkin to reach its maximum height? What is the maximum height? Oh, friends, I'm going to that Desmos calculator. So I'm going to switch back, go back and forth here. And I'm going to put in that equation. Now for h, you're going to have to put in y equals because that's all that Desmos understands. You've got negative 16. I think you're going to have to use x squared. Remember, shift 6 to use that squared. Now use your right arrow to come out of the exponent and plus 150x plus 20. Now you're just seeing you're seeing these purple lines, okay? You can use the plus or minus here to zoom out. You see how Desmos is coming out till you can see the top. Because when we talk about maximum, we want to see the top. And you see that point there that Desmos has for you. There it is, okay? Now, question asks us, how long does it take the pumpkin to reach its maximum height? That is x. So let's just say the pumpkin reaches the max height of, okay, so how high was the maximum height? That's our 371 point, it says 100, round to hundreds, 56 feet at 4.69 seconds. Now, do you see where I got those values from that point in Desmos? Okay, I used it to be able to graph it, but then I've got to know which one's which. I've got to know that the X is the time and the height is the Y value there. Okay, good job with that one. Keep that Desmos graphing calculator handy. We probably will be switching back to it, and that's okay. I wanted you to be using it on your exam. Work smarter, not harder, right? Notice on this one, we're being told to use the zero product property. That's a super easy one. You're going to take each of these things, the 5x and the 3x minus 2, and you're going to set them equal to 0, and you're going to solve. So we undo multiplying by 5 by dividing by 5 so that x is 0. We undo subtracting 2 by adding 2. That gives me 3x equals 2. And then we undo multiplying by 3 by dividing by 3 so that x is 2/3. I get 2 solutions for this one, so make sure that you get both of them.
Let's use the quadratic formulas to solve this equation, and then we'll be sure to round if necessary. So I want you to look here in the bottom left corner. You can see the quadratic formula, but more specifically, I want you to see that the equation needs to be equal to 0 first. So we're going to move the 5x over before we can actually tell what A, B, and C are. So you'll notice that I am putting the left side of this equation in standard form, meaning I'm putting it with the powers going down so that I can identify that A is 1, B is 5, and C is 4. Now I'm going to make these substitutions in our quadratic formula. So I have that x is negative b, so that's negative 5, plus or minus the square root of b squared, so that's 5 squared, minus 4 times a, which is 1, times c, which is 4, all divided by 2 times 1. So let's simplify underneath that square root. So I know that 5 to the second power is 25. And then I know that 4 times 1 is 4, times 4 again is 16. And then, of course, 2 times 1 on the bottom is 2. So again, underneath that square root, I can do the subtraction. 25 minus 16 is 9. And friends, we know what the square root of 9 is, don't we? It is 3. Now, be careful here. You have two solutions. Let's break them apart. One of them is negative 5 plus 3 divided by 2, which would be negative 2 divided by 2, which is negative 1. The other one is negative 5 minus 3 divided by 2, which would be negative 8 divided by 2, which is negative 4. So we actually get two answers here. We get x equals negative 1 or x equals negative 4 for our solutions to this equation.
And we're being told that a model rocket is being launched. And forgive my exponents, I will fix this on yours. But then we're being asked, how far horizontally from its starting point will the rocket land? Well, that sounds like a great problem for our friend Desmos. So I'm going to switch over to our Desmos graphing calculator. And by the way, I'll link the graphing calculator in the description below so that you're able to use it quickly. When we're in Desmos, we'll go ahead and type in our equation. Y equals negative 4.9. You'll have to use x here instead of t. X, then use your caret, that's shift 6, and type a 2 for your exponent. Use your right arrow to come out of the exponent and type your 39.2x plus 5. Remember, it's asking us how far horizontally from its starting point will the rocket land? Well, the rocket's going to land when it comes back down, right? And so we're looking at this value here. Did you see how when I moved my cursor on that point, Desmos told me the value? Love that about Desmos, right? And so we're going to get 8.126 feet. And so that we know you showed your work, because y equals 0 on the graph. If you'll make sure to include that statement, you're going to be just fine for this problem having work for it.